In this video, we're going to be talking about Pythagorean inequalities. We can actually use the Pythagorean theorem with a slight tweak to figure out what type of triangle we're dealing with. So the Pythagorean theorem tells us that if a squared plus b squared equals c squared, we're dealing with a right triangle. We can only use this equation when we deal with right triangles. However, if we change that equal sign to an inequality symbol, we can actually compare the sum of the squares of the two smaller sides with the square of the longer side and figure out two more types of triangles, whether it's acute or obtuse. So if a squared plus b squared equals c squared, that's a right triangle. If you take your two smaller lengths and you square them and you find their sum, and then you compare that to squaring the hypotenuse, which is no longer the hypotenuse because we're not in a right triangle, so we just call this the longest side. If you square the longest side, and that turns out to be smaller than this value that we simplified over here, then that's an acute triangle. And one last time, if we do the exact same thing, but this time we square the longest side and it turns out to be bigger than the sum of the squares of the two smaller sides, then that's an obtuse triangle. So sometimes these get confused and flipped. So the way to keep it straight is always take a look at the right side here. Always compare the longest side squared. If that is a smaller value, think about a small triangle or think about a small angle, and that will hopefully remind you that that is an acute triangle. And again, over here, if you focus on looking at the longest side squared and that value is bigger than these values over here, then think about a big triangle or a big angle, and hopefully that reminds you that it's an obtuse triangle. So that's essentially what we're doing. Let's do some practice here. The first thing we want to do is figure out if it's a type of triangle. So if it's not a triangle at all, if the three lengths given do not even create a triangle, then there's no reason to figure out what type it is because it's not a triangle. So we always want to take a look at the three values given and determine if it's a triangle first. And the way that we do that is by adding up the two smaller sides or the two smaller lengths and making sure that that sum is bigger than the third side. So 6 and 7 are the two smaller sides. If I add them up or find their sum, I get 13, and that is bigger than that third side, 8. So yes, these lengths do create a triangle. Now we can figure out what type it is by using the Pythagorean inequality test. So we're going to keep all of our values in the same exact spot, but we're going to leave a little blank for that comparison. I don't know if this side is going to be equal to, smaller than, or bigger than this side. So we're going to square each of our values just like we do in the Pythagorean theorem. So 6 squared is 36, 7 squared is 49, and 8 squared is 64. I'm going to add up the left side here. So I get 85. Now how does 85 compare to 64? Well, let's look at the right side and focus on that. Focus on the bigger side squared. That seems to be smaller. So let's think about a small angle or a small triangle. That's an acute triangle. Take a look at these lengths. The two smaller lengths, or the two smaller sides of this possible triangle, are 9 and 6. So we want to test to make sure it's a triangle first of all. 6 and 9 add up to 15. So the sum of the two smaller sides is not bigger than the third side. So this is not a triangle. I don't care what type it is because it's not a triangle to begin with. Let's take a look at these lengths. Figure out the two smaller sides or two smaller lengths. So 7 and 8 are the two smaller sides. Let's see if their sum is bigger than the third side. 7 plus 8 is 15. Yes, that's bigger than 11. So these lengths create a triangle. Let's figure out what type of triangle it is. So we're going to square all of our lengths. 7 squared is 49, 8 squared is 64, and 11 squared is 121. Let's figure out how these compare. Add up the left side, we get 113. So how does 121 compare to 113? We're focused on the right side, focus on that longer side squared. It's bigger, so we think big triangle or big angle. That's an obtuse triangle. One more example. Sometimes side lengths are irrational values or radicals. So the first thing you want to do is be able to compare these number forms. So I'm going to turn this into its decimal form so I can compare it easier. Square root of 10 is about 3.16 or 3.1 or 3.2. That's enough to figure out which are the two smaller sides and which is the biggest. So the square root of 10 is actually the longest side. So if I add up my two smaller sides, is that sum bigger than the longest side? Is 1 plus 3 bigger than 3.1-ish? Well, yeah. So these lengths do form a triangle. Let's figure out what type of triangle it is. So keeping everything in the same spot, we're going to square everything. 1 squared is 1, 3 squared is 9. And the square of a square root cancels each other, and we're just left with that number. So how does 1 plus 9 compare to 10? Well, 1 plus 9 is 10, and that's equal to 10. So if a squared plus b squared is equal to c squared, then we have a right triangle. So there's all the possible variety of problems that you may see. If the three lengths don't give you a triangle, don't bother with the Pythagorean theorem or inequality test. It's not a triangle. But if they do form a triangle, then you can just use these comparisons.